Now in this video, I have the NPN2N2222 transistor. The volt source is 10 volts. I have a 500 ohm resistor on the collector, a 100 ohm resistor on the emitter, and I've got a 1 mega ohm potentiometer on the base. The potentiometer is a variable resistance. And what that means is that while in circuit, I can change the resistance. Now what I want to do is, I'm going to take the resistance and I will adjust it upward so that I will have 5 volts across the 500 ohm resistor. Now when I have 5 volts across the 500 ohm resistor, I will have a collector current of 10 milliamps. And that collector current will flow down the front of the transistor and flow through the 100 ohm resistor. And when the 10 milliamps is flowing through the 100 ohm resistor, I'm going to have a voltage of 1 volt. Now across the base emitter junction, I'm going to have a voltage of about 0.7 volts. And across the collector emitter, I'm going to have a voltage which will be the difference between the 10 volts plus the sum of this voltage and this voltage, which will be 6 volts. VCE will therefore equal 4 volts. 4 volts. And now the base collector voltage, which will be from right here to right here, I'm going to call it a VBC. That voltage will be the difference between 0.7 volts and 4 volts. Minus 4.00 volts plus 0.70 volts. That gives you a voltage of minus 3.3 volts. Now the voltage across the 1 mega ohm potentiometer will be the difference of the 10 volts the voltage across at the base resistor, VBR, will be equal to 10 volts minus the sum of 1 volt plus 0.7 volts minus 1.7 volts, and that will give you a voltage of 8.3 volts. So the voltage of this resistance will be 8.3 volts. Now, in order for me to get 5 volts here, 4 volts here, and 1 volt here, I will have to adjust the 1 megohm potentiometer so that I have a resistance of about 140 k ohms. That is 140,000 ohms. Now the current flowing through the base, I'm called IB, that will equal 8.3 volts divided by 140 k ohms, kilo ohms, and that will equal 59.2 microamps. So we have 59.2 microamps flowing through the base. So we have 10 milliamps flowing through the collector, okay, now we're talking about the emitter current. Okay, we have 10 milliamps flowing through the collector, and we have 59.2 microamps flowing through the base, which flow through the emitter, which flow through the resistor. 59.2 microamps. And the total will be that will be a total current flowing through the emitter of 10.059 milliamps. And this brings me to the end of the video. Like, share, subscribe. Like, share, subscribe. Thanks for your attention.